Okay, so continuing on with our variables on both sides, when we look at example 4, we have both a combined like terms and variables. So if you look at it, we have 3 b's existing in our problem as it is. Our first step is that we're going to want to combine those like terms. So by combined like terms, again, I'm looking, here is my equal sign. What b's are on the same side of the equal sign? So that would be these b's. So we're going to take b plus b, which is 2b, or not 2b. In this case it is. Plus 18 equals 4b. From here, now I need to get my b's to one side. Well, the only thing on the right-hand side is b, so I'm going to subtract 2b from both sides. And so 2b minus 2b zeroes out, and I'm left with 18 equals 2b. And so that was the subtraction property of equality. From here, I want to get b by itself, so I'm going to divide both sides by 2, so that this divides to 1. And so that'll be the division property of equality. And then 18 divided by 2 is 9 equals b. And again, you can plug it in and double check to make sure that your answer is correct. I'm not going to do that on this one. And once again, just so that you hear this multiple times, the work that I show on your slides should be the same type of work that I'm seeing on your papers, not just problem and answer. I actually want the work point of the paper. Alright, on this one we're going to use a skill to get rid of the fractions. So you can use all those skills that we used when adding and subtracting fractions. Excuse me. Ugh. When adding and subtracting fractions in our review unit, but I prefer to use my multiplication property of equality, and I look for that least common denominator, and that's what I multiply both sides by. So in this case, the least common denominator is 2, so I'm going to multiply both sides by 2, and so on this side we're going to distribute that. So 2 times a negative 1/2, so positive times negative is negative, and 2 times 1/2 is 1, or half of 2 is 1, so we have a negative 1c. Now I'm going to take 2 times the negative 5, which will give us a negative 10, equals, and then again 2 times 1/2 is 1c. So that was that multiplication property of equality. Again, on this one, I only have the 1c on the right. There's no other constants, so I'm going, and this is negative, so I want to add it anyway. I'm going to add 1c to both sides. So that's the addition property of equality. This becomes 0. We're left with negative 10 equals 2c. We're going to use the division property of equality and divide both sides by 2, so that negative 5 equals c. And from there I can double check, so a negative 1/2 times negative 5 minus 5 should equal 1/2 times negative 5. And so when I take, this would be 5 over 1, so negative negative makes it positive, so we have 5 over 2 minus, I'm going to change this into halves, right? If this is 5 over 1, I take both of these times 2, so I end up with 10 over 2 equals, and on this case it would be a negative 5 over 2. And then 5 halves minus 10 halves is a negative 5 halves, which equals a negative 5 halves, which means that negative 5 is indeed the correct answer. So again, we could have added 1/2 c over and then gone from there. Perfectly fine. I just like to get rid of fractions, and if I have us practicing that now with these slightly easier ones, then when you get harder fractions in your equations, they become easier for you as well. Alright, so here again, I have a decimal, I have variables on both sides of the equal sign. Again, I'm going to start with a MPOE and just get rid of that decimal. It's only one decimal place, so I'm just going to multiply both sides, or everything, by 10. Both sides, everything by 10. The same thing. So 10 times 2 is 20D. 10 times 9.7 would be 97. Equals 10 times negative d is negative 10. Minus 10 times 17 is 170. So that was our multiplication property of equality. Now, oops, silly me. Next to that 10, oops, I'm just erasing a whole bunch of stuff. Next to this 10 should be a d, negative 10d minus 170. Something didn't look right. Alright, so I would rather have positive variables, so I'm going to add 10d to both sides. And again, I'm doing the opposite because our variables are on different sides or opposite sides of the equal sign. If they were on the same side, I would just do as it says. Alright, so 20d plus 10d is 30d plus 97 equals a negative 170. So that was an APOE. Now I'm going to do an SPOE because I'm going to subtract 97 from both sides. And so when I subtract that 97, because these are both negative, I'm actually going to end up adding. And so I will get a negative 267. And then I'm going to do a division property of equality and divide both sides by 30. And so then D will equal a negative, because negative divided by a positive is a negative, 8.9. And if you're sitting there going, oh, but Mrs. Cartwright, can we have a decimal? It's a decimal, it's not even. Again, before you have your freak out with me, double check it. I'm typing into the calculator now 2 times negative 8.9 plus 9.7. And this can be as easy as it is. You plug it into the calculator, I got an answer of a negative 8.1 for the left-hand side. And then I do the same thing. Negative times a negative, don't drop your negatives, 8.9 minus 17. And so when we do that one, then I get, again, a negative 8.1. They are equal, which means that the negative 8.9 is correct. And I believe that was our last one for this video. So again, there is a difference between variables on the same side. Nope, it's not going to let me write. Of the equal sign and variables on different sides of the equal sign. If they're on the same sign, we're just going to combine like terms, either adding or subtracting as it says. If they are on different sides, then in order to move them to the other side, we have to do the opposite operation. So keep that in mind. And until next time,